All right, next one is number 15. All right, we're finding regression line this time, so I'll just go ahead and do a simple linear regression. So stat, regression, simple linear, and then just select your x variable to be hours spent on studying, y variable to be test score. But I noticed something else. It says that they want us to estimate or predict the y values when x is 3, 3.5. So take a look. Scroll down a little bit and tell them to predict some y values for you. So type in 3, 3.5, 14, and 4.5. And just do hit compute. And we got the regression, so let's go ahead and type that first. The slope is what? The slope is 5.53, so you put that in front of x, okay? And the y-intercept is 35.3. Oh, they want us to do 3 decimal places. I have to be careful. Follow these rounding rules carefully. And 3 decimal places for the y-intercept too. And that's how you can find the regression equation. Oh, what do you mean? All right, let me try again. So did I round incorrectly? 5.535. Yep. And the y-intercept is 35.307. Oh, sorry. They want the y-intercept to be 2 decimal places. They are picky today. So they wanted 2 different rounding rules for that. Okay, now they want us to find the scatter plot, and we actually have it right here. We just have to click on right, and ta-da! Which one of this looks the same? Well, first of all, D is out. A is out because the lines on A and D are going down from left to right. So it's either B or C. And I think it looks more like this one. Okay, because I have 1 dot that's below the line. I have 2 dots on top and in the bottom. Yeah, this gotta be it. This is it. So C is the scatter plot. What else do they want us to do? Oh, they want us to do the prediction. Okay, now look, when I was making this table, I actually already told them to predict all these y values. So when x was 3, predicted y value was 51.9. And of course, you can do this by plugging in 3 into the equation, but it's convenient. When x is 3.5, y is 54.7. All right, and what's next? Now we have to be careful though. I'm thinking about this. Look at the x values. Look, of course I can tell them the number is 112.79. I almost clicked on C because I wasn't really thinking about this, but there is a 4th option that's called not meaningful. Now take a look at this for me. Look at all the x values. People are studying 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 4 hour, 6 hours. But now I'm talking about somebody who's actually studying 14 hours, okay? Compared to the x values that were given in this table, 14 is just way out there, okay? We were interpolating. Now I'm getting my word mixed up. Interpolating. Yeah, we were interpolating when we did the first 2 answers, okay? If x equals 3 and x equals 3.5 were reasonable. They were within these values, right? Like from in between 1 and 6. But x equals 14 is way out there, okay? Like nobody studied more than 6 hours, right? So it's when we do that, when we use an x value that's way too big to predict outside this given x values, we are doing something called extrapolating, and that's not safe. Extrapolating. We are doing something called extrapolating, okay? I can read this definition for you. We are extending a graph by inferring unknown value from trends in the known data. We really shouldn't do that, okay? So I'm going to click on not meaningful because 14 was way outside this x value range that was given, okay? And that's what they wanted. But the last one, if you look at 4.5, that's fine. 4.5 is in between 1 and 6, so I'll go ahead and say the answer is 60.2. That is meaningful. And that is it for this question. And this one was question number 15 on Module 8 homework.